Hello everyone, today I'm going to show you how you combine struct and pointer to make a linked list. So what is a linked list, you may ask? So linked list is a data structure that is made up of nodes where each node stores the data and a pointer to the next node. It is similar to an array, but uh, linked list is more dynamic and you can insert and delete data more quickly on a link, more efficiently, not quickly, on a linked list. So basically, to make a linked list, you need to make a struct and this. This is the struct of a linked list. This is the data. It can be anything. It can be float. It can be string. But for this case, we are going to make an integer. You also can have multiple data. It works like this also works. We're going to use one data only for this. And then another thing that will be used here is this pointer, this arrow. How it works is like this. One, two, to remember. And this is equal to pointer dot member. So basically this is just the shorthand. You will see me using it throughout the code here. Okay, so there are several types of linked lists. There are singly linked lists, there's doubly linked lists, and circular based linked lists. Here you can look at it. Singly linked list is basically just point to the next node until it reach null pointer. For doubly linked list, it stores the next node and the previous node. So basically there's two pointer. Circular linked list, at the tail it points to the head. That's the difference. However, today I'm going to explain about singly linked lists only. Okay, so to create a node, you can do this. Node star head equals to new node. So this will make a new node. And to fill the node, we can use and the next into null, or more generally null pointer. Null PTR and null is different. Null PTR means null pointer and null is null. It's different. In this case, we're going to make a null pointer. And here is how you make a singly linked list. A single linked list. Okay, so to use a linked list, you generally make several functions or procedure, if you call it in SIT 102. First one is insert beginning. It requires the node and the pointer address to the head and the data. So you make a new node and then you point the new node to the data. Point the new, point the data of the new node, this one, to the data, and then you point the new node next to the head. Oh, there's a typo here. And then you set the head to the new node. This is how you insert the node on the beginning, and then you can also insert it at the end. So the parameters are exactly the same. And then for the beginning, it's also the same. The different thing is that instead of putting the next pointer to the head, you put the next pointer to null pointer. So there are several cases. No, not several cases. There's a special case that need to be handled. That is when the list is empty. So basically, it will set the head to the new node, and it will return. If the special case doesn't happen, then it will make a temporary pointer, and that will be used to go over the list from this while until it reach the null pointer, until it reach a node where the next pointer is null pointer, and then it will set the temporary to this, set the temporary pointer to the next, and set this to the new node. You can also delete a node. When deleting a node, there are three cases. The first case is when the list is empty. So if head, wait, yeah, if head equals to null ptr, then it will return because the list is empty and there is nothing to delete. The second thing is when deleting, and when the value is at the head. I forgot to mention that this is deletion by the value, so it will search for the value. Okay. So if the data is the same, if it founds and it's at the head, it will make a temporary node, store the head to a temporary pointer. Wait, okay, like this, and then update the head to the next node and delete the old head, and it will return to stop the it from continuing again. And then the third case is when the value is at the middle or at the end. I'll temporary next. Okay, so basically if check if the next is null pointer and the temporary next data is not equals to the data. The temporary next, yeah, okay. It will check if the next node is, it will traverse the list until the temp next data equals to value. And then it will update the temp next. So temporary. It will update the temporary next to skip the node to be deleted. Hmm. This is, and here's a case when the value is not found. Here's where it deletes. And delete to delete. So here's how you delete a node by value. And then you could also traverse a node. So you generally start from the head to the tail. Create a temporary node and you go over it until you reach null pointer. To make it more aesthetic, I'm going to use an arrow here. And then you set the temporary to the next node. And then when it reaches the end, I'm going to print null pointer because the next pointer is null. Yeah. And there are no more nodes to go through. Okay, so generally you first set the head to null PTR, and then let's insert some nodes. Okay, insert n, and then we can insert beginning. Let's say 5, 15, 25, 35. Okay, change this to beginning. Semicolon, semicolon, semicolon. Uh, and this will insert the node. And to look at to traverse the node, we can call the traverse function and call the head. And an example, we want to delete a node 25. We can do it and we traverse it, and delete another node 55, and then we traverse again. And then we can maybe insert another node, insert at the beginning, head 100, let's say, and then we traverse again. Let's see if there are any error in the codes. Oh yeah, I forgot to put the semicolon here. Okay. Oh yeah, there's a mistake in my code. I just realized that right here, it's not supposed to be this because if it's if it's this, it will prematurely delete the data. And to fix it, we set if the next is null pointer. If this is the case, then the code will work functionally as properly, I mean. And when you run it, this is the output. So we can try inserting another node and deleting it. Okay. Insert beginning, and this is supposed to work. Oh yeah, it's work. Okay, so the problematic part is this one, and this is the fix. So here you have created a linked list. So the conclusion is linked list basically is a collection of nodes that points to each other, and they can store data. To traverse a linked list, it's much more complicated compared to an array, but it is more efficient, and it can be used in many cases. It is also dynamically allocated. The memory might be used in some cases, especially in data structures.